Hello everyone. In this video, we will continue to solve for fractional equations. Before I start example number 2, I would like to review quickly to everyone what we have done in previous video. The step to solve for a fractional equation is to apply distributive rule if any, simplify both sides of the equation by combining like terms, then we isolate the unknown by performing the same operation on both sides of the equation. Then the last step is to check the answer by substituting the solution into the original equations, and we emphasize the use of the calculator. Alright, so to start with example number 2, we see that there's no brackets for us to clear. So we don't have to apply the distributive rule. The next step is to simplify by combining like terms. So the left-hand side of the equation, we don't have any like terms. Right-hand side of the equation, we also don't have any like terms. So in this case, we have to start with the step that we need to isolate the x. Okay, so in this case, we see that the operations involving fraction will apply because the coefficient in front of x now is a fraction. So even though we see fraction here, all the fundamental steps to solve a linear equation still apply. Alright, so I will isolate the x by, first of all, I see this is subtraction 6, so I will add 6 to both sides, okay? And then at the same time, I see that subtract 6 over 7x, that means I will add 6 over 7x to both sides. So let's start it with that. So I will have 12 over 7x subtract 6, so I'm going to add 6, alright? So that means on this side, I also have to write add 6. Okay. Then let me write 15 subtract 6 over 7x here. Alright, okay. So I need more room. So I'm going to just give myself some more room. I do 2 steps at once. So that's what it is. We do 2 steps at once. So this is 15 subtract 6 over 7x. Okay, so we add 6 to both sides. Okay, very logic. We just apply the step. That means that is gone. Alright, now the next step is this one right here. That means I said I add 6 over 7x on both sides. So I do the same thing here. Add 6 over 7x. Alright, okay. Okay, so I add 6 over 7 times x on both sides of the equation, and that will give it the x isolated to the left-hand side of the equation. So let's see what we have next. Okay, we have 12 over 7x, add that with 6 over 7 times x equal to 15 plus 6, so it is equal to 21. So we may as well combine the like term, adding 15 to the 6 right away. Okay, so before I get into how to perform this operation, I want to do a tiny example on the side. Okay, so let's do a tiny example. Then what I will do is to erase this right after. Okay, so let me ask you this question. You have 2x plus 3x. So what do you get? You immediately tell me that 5x, right? It's more like automatic because we know. Because what you do, you take 2 plus 3, right? So 2x plus 3x equal to 5x. Then I can ask you the same question here. If you have 12 over 7x plus 6 over 7x, so what do? You just add the 2 coefficients in front of x. So because this is the like term that we are talking about, so the coefficient of x in terms of whole number and the coefficient of x in terms of fraction, it works the same. Okay, the same fundamental step that you are adding the coefficient and then you leave the x alone. Okay, so then what I do is I erase this tiny example just to verify with everyone. Okay, so but let me go back to that tiny example that I show everyone. And then you say is equal to 5x. Automatic, very simple. But can I write it like this? Yes, I can, right? So 2 plus 3 times x is the same thing as 2x plus 3x equal to 5x, right? So this added as 5 times x, so then I have them equal to the 5x. This is in terms of notation, okay? In terms of notation, then you can take 2 plus 3, or I can write 2 plus 3 in the brackets and still give me 5x. So the reason I am writing this is because I want to clarify this with everyone, that I will take 12 over 7 plus 6 over 7 like that. Okay, it's the same thing. You take 12 over 7, you add that with 6 over 7. The way I wrote it like this is just to simplify. Okay, to simplify and also to clarify with everyone that I'm adding this two coefficient in front of x, and in this case it just happened to be a fraction. Okay, so let's erase that, and hopefully that will clarify that if you solving for a linear equation, and if that linear equation involving fraction and all the fundamental algebra basic steps to apply. Okay, so if you take 12 over 7 plus 6 over 7, what do you get? Okay, so if you forget how to add fraction, you can use a calculator, but I can tell you that because it's the same denominator, all I have to do is just I leave the denominator the same, and then I will just add the numerator. So in this case, I will have 18. Okay, now I have 18 over 7 times x, right? So I want to get rid of this. That means I divide both sides of the equation by 18 over 7. So I do the same thing here. Okay. The purpose is to get rid of the coefficient in front of x, and I just end up with just x equal to 21 divided by 18 over 7. Right? Okay, so 21 divided by 18 over 7 in the brackets, I can go ahead and write it like this. Nothing wrong with this. And if I perform the operations of fractions, that means you need to invert the fraction, and then you change that to a multiplication. Okay, so if you forget to perform this step, you can go ahead and use a calculator. I can tell you that if you use a calculator, take 21 divided by 18 over 7, it's end up to be the answer as 49 over 6. Okay, so use your calculator to check the solutions that I just got. Okay, so now what I have here is I can show everyone the quick way to do this as well. So 21, I can simplify that with 3. So that will give me 7 left. And simplify that with 3, I should get 6 left. So I divide the 21 by 3. I divide the 18 by 3. So I got 7 and 6. So 7 times 7 is 49. And then 6 remain as a denominator. Okay, so let's check the solution. Okay, so check the solution. Left side equal to, and then the right hand side equal to. So the left hand side is equal to 12 over 7x minus 6. Okay, so that means 12 over 7 times 49 over 6. subtract 6. Okay, so in this case, what we have is you must perform the math correctly. So I multiply the two fractions first. So this will give me 2. That cancel out with that. And that 49 divided by 7 will give me 7 left. So that means I will get 14 and then subtract with 6. So the answer is equal to 8. Okay, so now the right hand side. So the right hand side is equal to 15 minus 6 over 7 times x. So I have it as 15 subtract 6 over 7. I multiply that with 49 over 6. Alright, so then you see that cancel with that. 49 with this will give me 7. So then I will have 15 subtract 7 and then it's equal to 8. You see? Yeah. So left hand side equal to the right hand side. So that means we conclude that x is equal to 49 over 6. Alright. Alright, okay. So let me perform a slightly different method to solve for x. Okay, because many of you probably being taught that if we have an equation involving fraction, we will have to look for common denominators and then eliminate the common denominator on both sides of the equation. I will do that for you as my next method of solving for this. But the purpose of this method of showing everyone is to tell you that solving for linear equation, all the steps still apply. Involving the fundamental step of algebra and also isolate the unknown, and you don't want the fraction to confuse you. Okay, working with fraction is still apply the same step as we've done before, right? So that like on this side I multiply by 18 over 7, then I divide both sides by 18 over 7. Is nothing wrong with that. So in this case I do the same, then I perform the operations of fraction and I still end up with the correct answer. Okay, so I will quickly go over the other step, which I feel that many students probably think why I am using this method. This method is more like we are clearing fraction. Okay, so in this case I will approach it with using the common denominator. Okay, so let's try this again. 12 over 7x plus subtract 6 equal to 15 subtract 6 over 7 times x. Okay, so this is similar to, I better write it here as method 2. Okay, so it's the same thing as this. I will write this over 1 because I am going to start with the operation of finding the lowest common denominator right away. Okay, so that means many students will do this. I convert this all to fraction and I start finding the common denominator for all of this fraction. So the common denominator should be 7. Okay, so that means you have 12 over, so 7 times 6 would be 42 over 7. And 7 times 15 would be 105 over 7. Okay, so the next step is, so what is the purpose of getting the common denominators? Is to perform the operation on top and keep the denominator the same. So that's exactly what I just did, right? Okay, now I will multiply both sides by 7 to get rid of it. So it's still the same thing, right? Perform the same thing on both sides. So perform the same thing on both sides. The purpose is to get rid of the denominator altogether. So the next step, now turn this equation into a linear equation without any type of fraction involved. Then perform operation on both sides, the same operation. So I do step by step. Alright, I will do step by step because I don't keep myself enough room. So 12x, subtract 42, add 42. So I add 42 here too. Alright, okay, so this will cancel out. So I want to take this plus that. So this will give me 105 plus 42 will give me 147. Okay, so the next step is I am going to add 6x to both sides. So I add 6x to both sides. Excuse me. So then this cancel out. So what do I have left? I got 18x equal to 147. I divide both sides by 18. So x is equal to 147 divided by 18, but I simplify by reduce the fraction to lowest term. I divide the top and the bottom by 3. So divided by 3, I should have 49 as the numerator and then 6 as the denominator. So therefore, I still have x equal to 49 over 6. Okay, so let's see which method is more simple. So to me, it's entirely up to you. The method 2 involving the expertise in working with fraction. So you really have to be knowing your fraction really well in terms of finding the common denominators, perform the equivalent fractions, and get all the correct answers, right? So for this one, you rely on the calculator to work with. And when you rely on the calculator, you still have to think of the fundamental step of operating the fraction and also involving collecting like term. And if the like term and the coefficient of the x involving fraction, you just perform the exact same process as is a whole number. So don't let the fraction confuse you. Okay, so in this question, I show everyone two ways of solving for this equation. Alright, so I really don't want to rush again. Alright, usually if I rush, I tend to make some silly error. So I will leave example 3 to the next video. Alright, okay, so if you have any questions, feel free to send me an email. And I believe that I have quite a few practice for everyone to work on. Alright, a solution is posted online. Thank you, everyone.